Let's go to share. All right, my name is Grayson Hartson, and this is Lab 5 of Electric Circuits and Current. Now, this might be a little cheesy, but the goal of this lab was basically to create simple circuits and then test how they work, and just to build an understanding of how circuits work. And background concepts, a closed circuit is needed for a bulb to light, or really a closed circuit is needed for the electrons to travel and get all the way around. And basically what we ended up finding out was like removing the bulb from these circuits also disconnects it. So it has to have a full connection. And right here you can actually see this is a pretty basic circuit with our multimeter hooked up, but one end is going to one end of the battery, the other end is going to the other end. Now our prediction models, which was activity 4, basically we're given 5 different models, and 3 of them belong to one group, 2 to one group as kind of choices. So model A was current travels from the battery to the bulb in both wires. And then for B, it was current travels toward the bulb in one wire, away in the other. And for model C, current flows in one wire is used up, none flows in the other. Now, of these 3 options, I chose Model B as my prediction, which is correct. Current actually travels from one side of the battery, specifically the negative side. The electrons travel around and then to the positive side, through the bulb and to the positive side. And then we had to pick from Model D or E as well. Current is unequal on each side, and then current is equal on both sides. Basically, is the current the same in both wires? Like you have your battery, you have your bulb, and this wire connecting them. Are they the same current or not? And Model E is my prediction and is correct. Current on both sides are equal. Now, for measuring current, we had to use a multimeter. Basically, we put it in place of a wire in the circuit to measure the current. Your positive and negative on your multimeter indicate your direction of the current, and our measurements were taken on both sides of the bulb. Yeah. Now, this was circuit design number 1, basically. Tunnel lighting, like basically if you walked into a tunnel and you turn the light off and you walk to the second light to go out the other side of the tunnel, you can use that light to turn it off. So we'd use a single and a double switch. Basically, if you look here, you have these 2 black switches on the picture. A single is that one that just connects and disconnects. And then the double is where you switch to the other side, it turns something else on, it powers something else, while it doesn't power the other thing. Now, basically, one switch will turn on the first light, the other switch turns off the first light and turns on the second light. Now, I struggled setting this up, and one thing I found is that this doesn't work backwards. In this circuit I've set up here, it works coming into the tunnel, but if you're going backwards and the lights are off and you flip the double to basically light everything up, and then you go and flip the single, one of the bulbs turned off, one of them stayed on, and I could not really get around that. But regardless, this is basically how that kind of circuit is set up here, where the double, you can see the 2 yellow wires, each of them is going to a bulb. Um, it's going to each one of the bulbs. And then the one right here, the top one, is connected with the red wire, and the other bulb's connected with a green wire to the same spot. And then you just have the simple single, which had a wire connecting, grounding it to the middle of the double, and then the white part of it going to the battery. This basically created tunnel lighting effect. Now, our circuit design number two is the Christmas tree lights, which basically, like if a bulb and you had a Christmas tree and all the lights were lit up, if you had a bulb that went out, the other bulb will stay on. So basically, if the connection on a bulb is broken, it's not going to just cut the whole circuit still run. And basically, we use three bulbs in this circuit. And our goal was if one of the bulbs failed, the others will stay lit. You see here, I have three batteries hooked up. And I set it up like this. There's one switch, which is coming the white wire right there. And that connects to this bulb. A red wire connects that to the other bulb. And this bulb right here connects to the other bulb. And basically what I did here was hook this green and red wire up, both going to the battery like this. So when I unscrewed one of them, it still continued in a sense. Um, I actually think this picture might be a little wrong here. Let's see. Yeah, this picture, there was another wire. I think I took this picture afterwards when I was taking it apart, but there is another wire that's supposed to run between one of the bulbs, and that makes it to where it could just keep going if any one of them. I think this particular setup, it was just the one right here at the end, I think, that was that you could take out and it won't, mess with it. Now for circuit design number three, we had entry and exit switches. Basically just two double switches and both switches will turn the light on and off. And now this one did work. This was probably one of the hardest to set up. I think I struggled a good bit with this. As you see in the side of the battery, the white wire going to that first double. And then you have the yellow here grounding to the bulb. And then the red here also grounding to the same way, basically. And then the green grounds to the middle of this one. And while this side of the double actually connects to the battery, and this one also ground goes back to the second bulb, or I mean, it's the only bulb here. And this one worked pretty good. I could on both ends. I think there's one situation here if this other double on the top was flipped a certain way, while the other one was here, it wouldn't quite work. It like turn it off and turn it back on. But it worked pretty good. Now, the summary of my observations, I found that current is the same on both sides of the bulb. Simulations support experimental results, which I'll talk about that in a minute. Circuits must be closed to work, basically. And the conventional theory is incorrect and opposite to how it actually travels. Basically, conventional believed that positive was traveling to the negative, while the reality was it was electrons traveling from negative around to the positive. Now, here are references. I used Lab 5 instructions, but here, this link right here, it goes to basically this like simulation where you can set up circuits and it has a little digital multimeter too. You can play around with it. And I actually used that to help me with a lot of these circuits, like just to set it up. I don't have any screenshots of it, but it was useful. I used it to see how the multimeter worked, how to see the direction of which it travels, and basically how to see like what's the best way I can set up the circuit for one of those three instances. It was useful, but that is all. My name is Grayson Hartson.